can't. But it is. It's paradoxical, and yet it works.
Hello Ziad. So a suitcase weighing 200 newtons is placed on a weighing scale in a lift. The scale reads 180 newtons when the lift is moving. So the lift is, and you got a choice. So you've got your lift, which is held up by a cable, and then you've got your suitcase, and then it's on a scale. Now we know the force exerted by the suitcase is 200 newtons. Now, what is the scale reading? So think carefully. The scale reading is a reaction to the suitcase. So it's the force upwards from the scale. Now, what is the scale connected to? What is it you're pressing down on, or the suitcase is pressing on the scale, which is pressing on the floor. So it's actually the reaction from the floor on the suitcase. Okay, so that's what the scale is reading. Now, look at the floor. The floor is connected to the lift, and who's pulling the lift up? The tension. So this value is actually the tension. So that is 180 newtons. Okay, so what do we know? Well, look at the two numbers. You've now got a resultant force of 20 newtons downwards. So because you've got a resultant force, it can't be A or C, because that's Newton's first law, which says the resultant force is zero. Well, the resultant force isn't zero. So we've got a choice. If you're moving downwards, so let's just draw the scenarios. If you're moving down with speed v, and you're decreasing the velocity, that must mean the acceleration is a negative acceleration, or it's decelerating. That must mean the resultant force is up. So it can't be that, can it? Okay, but let's just prove it's D. So if you're moving up with a decrease in velocity, that means your acceleration is down. That means your resultant force is down also. So it's got to be D. Okay.